So this is the last lesson from chapter 6. Tomorrow you're going to have a quiz on 6.3, 6.5. So that includes domain range, which we spent a lot of time talking about, as well as function notation, and now we're talking about slope of a line. Yesterday we saw that you can find the slope of a line by drawing it on a graph. You can construct a right triangle from that line, find the rise and the run, that gives you slope. Slope is rise over run. Then we saw that there's also a formula that can be used to find the slope of a line. The slope formula says that you can go y2 minus y1 all over x2 minus x1. And the nice thing about that is all you have to have is the 2 points. You don't have to graph it, right? So the slope formula will work to give you the slope as well. And when you find the slope, it's a number. It might be positive or negative. Remember, if the slope is positive, that means you're rising as you go left to right. When the slope is negative, you're falling as you go left to right. But also remember, the slope can be 0, and that is a flat line, a horizontal line. The slope can be undefined, which is a vertical line. We also said that as a point of reference, if a line makes a 45-degree angle to the x-axis, that is a slope of 1. So that can be used as a point of reference. You can also use slope to graph a line. So this example says the point negative 3, 2 is on a line that has a slope of negative 3/4. List 3 other points on the line and then graph it. Okay, so let's start with the point negative 3, 2, which is right there. We are told that the slope of the line is negative 3/4. So what you have to remember is that when a fraction is negative, it means either the top or the bottom is negative. This could be negative 3 over positive 4, or it could be positive 3 over negative 4. If the top number is negative, that means you're going to rise negative. And when the bottom number is positive, you're going to run positive. So what would that look like? Well, from the point negative 3, 2, we need a starting point. And that's the point negative 3, 2. We can rise negative 3, which means you go down 3, 1, 2, 3 down, and then run positive 4, which means you're going to the right 4. That gives us to the point 1, negative 1. That's a point on the graph. And we can continue that pattern. We can rise down another negative 3 and run another positive 4. We can go down 3 and to the right 4. And that takes us to the point 1, 2, 3, 4, 5, negative 1, 2, 3, 4. 5, negative 4. And we can do it again. We can rise another 3 down and run another 4 to the right. And instead of getting the point from the graph, you can get the new point from the previous point. If you rise negative 3, that means you're going down 3. That means from the y value of negative 4, you're going to go down 3 to negative 7. And if you're running positive 4, you're going to the right 4. That means from the positive 5, from the last point, you're going to add 4 to that and get positive 9. So that was rising negative 3 and running positive 4. But we said you could also rise positive 3 and run negative 4. So from our starting point of negative 3, 2, if you rise 3, 1, 2, 3 up, and run negative 4, you're going to go 4 to the left. Takes us right there. So that is the point negative 1, 2, 3, 4, 5, 6, negative 7, 1, 2, 3, 4, 5. And see, we also could have got that from the point negative 3, 2. If you rise positive 3, you're going to go up 3, which means the y value of 2 will be increased by 3. That's where the 5 comes from. And if you're running negative 4, you're going to the left 4. So from negative 3, an x value of negative 3, if you go 4 to the left of that or subtract 4, it takes you to negative 7. Now, we don't have room to run 4 to the left anymore. We can definitely rise 3 one more time, but we kind of run out of room to run 4 to the left. We can kind of guess where it would be. It would be over there. And the coordinates of that point would be, again, if you're rising 3, you're going to add 3 to the y value. So 5 plus 3 is 8. And running -4, you're going to subtract 4 from the -7, which takes us to -11, 8. But you see, all these points line up. So we can draw a line going through all these points. So that's what our line would look like. And whenever you draw a line, this is continuous data, you need to put an arrow on the end, on both ends, because that pattern continues forever. Unless you're specifically told that a graph has a starting point and an ending point, we always draw arrows on the ends. Whether it's a line or a curve, doesn't matter. Okay, so you can use slope in order to help you sketch a graph. We'll do the same thing with this one. The point is -6, 1. -6, 1 is right there. And this line has a slope of 1/3. So usually we would just say it's 1/3. However, we could also say it's -1 over -3. A negative divided by a negative also gives us a positive. Both of these will work. So starting from our point, -6, 1. If we rise 1 and run 3, that means going up 1 and going 3 to the right. Takes us to that point there. Now you can count where that is on the graph, or from our point -6, 1, if you rise 1, you're going to increase the y value by 1. So in the last point, the y value was 1. Increasing by 1, it becomes 2. And if you're running +3, you're going to increase the x value by 3. So -6 plus 3 is -3. That is the coordinates of that point. And we can continue that pattern. We can rise another 1 and run another 3. That takes us to the point 0, 3, which again we can get by rising 1, adding 1 to the previous y value, which was 2. 2 plus 1 is 3, and adding 3 to the x value. -3 plus 3 is 0. And we can continue. Rise 1 and run 3. So again, if you rise 1, the y value is increased by 1, and you run +3, the x value is increased by 3. So that takes us to the point 3, 4, which is what that point is. And we can continue. Rise another 1, run another 3. Rise another 1, run another 3. Or, as we said, you can also rise -1 and run -3, which means you go down 1 and you go 3 to the left. So that's that point right there. So from the point -6, 1, if you rise -1, you're going to go down 1. So the +1 value of y becomes 0. And you're going to run -3, go 3 to the left. From -6, if you go 3 to the left, you're at -9. -9, 0. All those points line up. So we can be fairly confident that we've done things correctly. Because all the points line up, they all form one line. And we always put arrows on the end. Notice in this case that this line rises as you go left to right because the slope is positive. On the previous example, the graph fell as you went left to right because the slope is negative. Now we'll look at a few applications of slope. The Brentwood Regatta in Mill Bay, BC is the largest junior rowing regatta hosted by a single school in North America. The races are all 1,500 meters in length. The graph shows the approximate times at the 500 meter mark and at the 1000 meter mark for one of the boys' races. Determine the average rate of change for this position of the race. So the rate of change is actually the slope. That's what slope tells us. One of the things it tells us. It tells us the rate of change. That's one of the applications of slope. And we can find the slope of that line by using the slope formula. Y2 minus y1 over x2 minus x1. So remember, we did this yesterday. Designate one of the points as point 1. Let's say that bottom point is point 1. That gives us our values of x1 and y1. So the top point will be point 2, which is x2 and y2. So y2 minus y1 would be 1,000 take away 500 over x2 minus x1, which is 180 take away 85. So that gives us 500 over 95. I think 180 minus 85, yes, is 95. Now, we can divide those two numbers, 500 divided by the 95, and it'll give us the slope as a decimal. But in this case here, it's a non-repeating, non-terminating decimal. Okay? So we'd have to round it, and that's fine. The other option is to take the fraction and reduce it. I think you can divide top and bottom by 5, which will be 100 over 19, I think. 95 divided by 5. Yeah, 19. So that's the slope of that line segment. That is the rate of change. However, in this case, we can actually tell what that number means. When we found the slope, we divide the rise by the run. You see, the rise is the distance in meters. That's what's along the y-axis. That's where the rise comes from. The run is the time in seconds. So not only can we say that it is 100 over 19, now we can say that it is also meters per second. Because the rise is the distance in meters, the run is the time in seconds. So it's meters over seconds or meters per second. That is the average rate of change. That's what you get when you join 2 points together. You're getting the average rate of change from one point to the next. And it comes from actually finding the slope. Right? So then this next graph shows approximate times at the 1,000 meter mark and the 1,500 meter mark for a rowing crew of girls that are in the Junior Open 8 race at the regatta. Now we want to determine the average rate of change for this portion of the race. So we can do it the same way we did the last one, use the slope formula, but we can also do it by creating a right triangle and calculating the rise and the run from that. Okay, so the coordinates of that point at the corner would have the same x value as the point above because it's the same distance away from the y-axis. Princess, what would the y value be there? Who? What did you say? You want to bet a pop on that? Is there an echo in here? Hello? Nope, no echo. We want the y value for the point that I just did right there. It would be 1,000. It's at the same height as this point to the left here. And the reason we do this is because you can also calculate the rise by subtracting the y values. This is what we did yesterday when we first started talking about slope. The rise can be found by subtracting the y values. 1,500 take away 1,000 is 500. And the run can be found by subtracting the x values. 297 minus 205 is 92. You can do the slope this way if you want, without using the slope formula. This works. And we did this again yesterday. All right? So, the slope, again, is rise over run. Rise divided by run. That'll be 500 over 92. And once again, the rise is the distance in meters. That's on the y-axis. The run is the time in seconds, so this would be in meters per second. And that can be reduced. We can actually divide top and bottom here by 4. And that'll give you 125 over 23 meters per second. And you know, if it does ask you to write it as a decimal, well, you can certainly do that. Whether you take the original numbers or our simplified values, they should be the same answer. Right? That's the simplified numbers. Our original numbers were 500 over 92. Same decimal. So approximately 5.4 meters per second. If you round to the nearest tenth. And once again, if you wanted to, you could have used the slope formula. You would have got the same answer. You would have got 500 over 92 using the slope formula. So, what we've learned about that, some slopes are positive if it rises as you go left to right. If it falls as you go left to right, that's a negative slope. A flat line, a horizontal line, has a zero slope. An undefined slope is a vertical line. Slope is the ratio of the rise over the run. And remember, it's a number. There's no units attached to it. But what it tells you how steep the line is compared to the horizontal, compared to the x-axis. If a line makes an angle of 45 degrees with the x-axis, that's a slope of 1. If the slope is greater than 1, the angle is greater than 45. But it's not proportional. A slope of 2 is not a 90-degree angle. In fact, a 90-degree angle, the slope is undefined. So it's not proportional. Just like a slope of a half does not mean the angle is half of 45. It's not true. You can find the slope using the slope formula. You can find the slope by counting on the graph. Count the rise and the run from one point to another. One of the applications of slope is the average rate of change. And again, it can be found by taking any 2 points and calculating the change in y over the change in x. That gives you slope. Okay, so we've had a number of assignments in this chapter. Today you should be working on page 325 to 327, questions 1 through 6 and 10 through 12. Nope, this one is not for marks. But what you might want to be doing is any of the previous assignments that you haven't got done and handed in, you should be working on those today and get them done and handed in. It's going to help you for this quiz tomorrow, right? Your quiz is on 6.3, which is domain and range, as well as 6.4, talking about what is a function, what is function notation, how we work with different equations, different functions, and then now talking about slope. That's what's going to be on the quiz tomorrow. And then we'll also be starting chapter 7 tomorrow. And then after chapter 7 will be your next exam. Okay? So 325 to 327, what you should maybe be concentrating on getting any of those other assignments done that you haven't handed in that count for marks. Everything's on PowerSchool, so you can look on there to see what you're missing. Thank you. Yeah, everything goes there. Thank you.